Hi, I am doing the Zoom report for written exam module 3. Number 1, we were given numbers and we had to use the divisibility rules to determine if what the divisors were for each of the larger numbers. This is really good in breaking down really large numbers fairly easy. The rules for 2, 4, 5, 6, 8, and 10 are fairly easy. So on these charts, you will see yes or no, which is letting us know if that number, like the 2, the 4, is a divisor of the larger given number. And for example, 684, yes, 2 is a divisor because the number ends in an even digit. For the divisibility rule of 4 for 684, yes, the last 2 digits form a number divisible by 4. So that will continue that way. When you get into the harder divisibility rules, and not necessarily harder, there's just more steps, then you will see that there's a yes or no on the chart, but we've broken those down step by step so you can see the work. We'll start with a simple one, 684. The divisor, we're going to look to see if 3 is a divisor. We're going to use divisibility rule for 3. So we add each individual digit that is in this number to figure out that divisor. 6 plus 8 plus 4 are all digits of 684 is equal to 18. Can 18 be divided evenly by 3? Yes, 18 can be divided by 3 evenly. Therefore, 3 is a divisor of 684. For the rule for 7, we're going to remove the last digit from the number. So in the number 684, we're going to remove 4. And we're going to double that last digit and subtract it from the remaining number. So 68 minus 8, because 4 times 2 is equal to 8, is equal to 60. 60 cannot be evenly divided by 7. Therefore, 7 is not a divisor of 684. When we go to look at the divisibility rule of 9, 6 plus 8 plus 4 is equal to 18. 18 can be divided by 9 evenly because 18 divided by 9 is equal to 2. Therefore, 9 is a divisor of 684. Divisibility rule of 11, that's a tongue twister. Find the sums of digits in odd places. So what you see is 684. 4 is in the first place, so that's odd. 8 is in the second place, so that's considered even. And 6 is in the third place, that's odd. So we have 6 plus 4, so the third place and the fourth place, when we start at the right going left, is equal to 10. Then the only number that's in an even place is 8. So 10 minus 8, because we're subtracting the smaller from the larger, is equal to 2. 2 is not divisible by 11 evenly. Therefore, 11 is not a divisor of 684. And you will see I continue to do this for each number. The first 3 numbers are in that first chart. And then next we have larger numbers, and that's the next 3 numbers, and that's in this chart. I followed the same protocol as the first. And then, let's see if I can find a good one to explain. And you follow the same steps. Here we go. We're using the same divisibility rules, and I've broke them down step by step. When we come to the divisibility rule of 11, for this number, let's see what we got. 2,676,740. Well, we're going to find the sum of digits in odd places. The odd places, 0, 7, 7, 2. We add those up. 2 plus 7 plus 7 plus 0 is equal to 16. Then we're going to find the sum of digits in even places. 4, 6, 6. Down here you see 6 plus 4, 6 plus 6 plus 4 is equal to 16. 16 minus 16 is equal to 0. The divisibility rule of 11 is if the difference of the sums is 0 or evenly divisible by 11, then 11 is a divisor. In this case, the difference is 0, therefore 11 is a divisor of 2,676,740. I shouldn't say and. It's 2,676,740. Okay, and we do the same methods and follow the same steps. For number 2, this is casting out nines. And in this step, we add, once again, you take each individual number and add the digits of that number. So we're going to use this number and add all the digits together. This number, add all the digits together. The third number and add all the digits together. So we're going to start here. 4 plus 1 plus 6 is 11. That's 2 digits, so we need to add those together. 1 plus 1 is 2. The next one, 7 plus 4 plus 9 plus 0. Well, we cannot add, and I meant to put 9, or we cast out. What I'm meaning by this, in casting out nines, if there's a 9 as a digit in the number, we can eliminate it. So 7 plus 4 is 11. 11 is 1 plus 1, which is equal to 2. And we do the same with our third number. 6 plus 9 plus 8 plus 4 plus 4. We cast out the 9. That gives us 22. 2 plus 2 is 4. Then we're going to add our sums, our digits up together from each row. And we have 2 plus 2 plus 4, and that's equal to 8. So now we're going to check, and that's what this is used for. It's to check your work before we had calculators. So in order to check our work, we had 8 here. We're looking to see if we're going to get 8 for our answer when we add the digits of our answer. 1 plus 1 plus 2 plus 7 plus 9 plus 0. 2 and 7 is equal to 9, so we know we can eliminate that because that's a casting out of 9. We can cast out that 9. So we have 1 plus 1, that's 2. 8 does not match 2, therefore our answer is not 112,790. Our actual number is 77,750. And I have worked each problem the same way. You can see our original problem, and we broke it down here. And then we add these numbers together here, and it'll give us 16. 1 plus 6 is equal to 7, and it does not match our answer. And then we have our actual answer. 3, we're using rods. And rods are a good hands-on way for kids to understand measurements and divisibility, our factors, multiples. It really is a good tool for kids to learn this. So what we're looking at here, each rod is a different color. So if we have 9 rods are all going to be the same shade. In this case, it is blue. Our 1 rods are white. Our 3 rods are green. So here we say which rods will measure the 9 rod. Well, and we're going to want this to be even measurements. So we take this 9 rod, and we know we can put 9 1 rods, and it's equal to the same length as a 9 rod. We also know that if we, and this is laying them end to end along the way. So we also know we can take 1, 2, 3 green, they're green, but it's 3 rods, and that is also equal to 1 9 rod. So if you can see, it's easiest, and that's why we put white in the middle, so that you can see 1, 2, 3 is equal to 1 3 rod. So if a child was manipulating this in front of them, they're going to see that I can take 3 of these green rods and stack them end to end, and it's going to equal to 1 blue 9 rod. And we do that again with the 6 rod, and we know we can use the 1, the 2, the 3, and the 6 rods, each type of rod, to get the measurement for the 6 rod. So 6 1 rods is equal to 1 6 rod. 1, 2, 3 2 rods is equal to the length of 1 6 rod. And 2 3 rods is equal to 1 6 rod. So for C, we're looking at what can go into each one evenly, and that is the 3 rod. Here we go. D, we're going to show all our rods or trains that will measure the 18 train. So we had a 10 rod and an 8 rod, and we put them together, and then we break it down to what color rods will give us the same as the 18 train. And how would we use this to help our students, our children? It's because they learn when they're hands-on. And these rods, if we have that green 9 rod, and we have 2 or 3 or 4 of a red rod, and we know that those are 2s, well, we know that if we lay those 2s end to end, that's not going to match the 9 rod. So we know 2 is not a divisor of 9. This just gives them a hands-on way to be able to manipulate something and see in action how this works. It makes it no longer an idea, but something factual. Number 4, we are using the table, and this was common in Asian countries. And this is, if you're used to using a factor tree, this is pretty much the same thing. We're going to use prime power factorization. Very easy, very fun. It's very organized. So we were given the numbers 48, 25, and 65. We start with the smallest prime number and keep using it until you can no longer use it in your problem, and then you go to the next smallest prime number, and we're going to work it that way. So here we start with 2. 2 goes into 48 24 times, so 24 goes under 48, and we write this 2 in here, so work this with me. 25, 2 does not go into 25, so we drop 25 down to the next row. 65 is cannot be divided evenly by 2, so we drop it down to the next row. 24 can still be divided by 2, so 2 goes into 24 12 times, so we put 12 under there. 25, not divisible by 2, so we put it down. Same goes with 65 again. 12 is still divisible by 2, so we put 2 to the left. It goes, 12 is divided by 2 6 times. We put 6 underneath the 12, and we drop the 25 and 65 because they're not divisible by 2. Next, 6 can be divided by 2 3 times, so 2 times 3 is 6. 25 and 65, once again, we drop them down because they are not divisible by 2. 3 is prime. So we don't have to look at that number any longer. We will have to drop that one down though. So we drop 3 down. Next is 25. Well, according to our divisibility rules, we know that if it ends in a 5 or a 0, it is divisible by 5. So here we're going to put 5 to the left as our prime number, and it goes into 25 5 times. So we write 5 underneath the 25. 65 is also divisible by 5 because of the divisibility rule. 5 times 13 is 65. So here we're going to count, and this is where it is very neat and organized. 1, 2, 3, 4 2s. There's no more 2s under here. So we're going to write this as 2 to the power of 4 times, and then we're going to go to the next prime number, and that's 3. And that's only used once. So 3 to the power of 1, or you can just write 3, and that 1 is understood. Times, the next number is 5, and that's used 2 times. So 5 to the second power. The way you would correctly say that is 5 squared. Times, and our last prime number is 13. And we put 13 to the first power, or you just write 13. And that is how you do prime power factorization using the grid. Now, if we look at B, B shows us that if you'll notice when you work through, you're going to get to a section, a spot where there's a 1. 1 is not a prime number. So when you write out your prime powers, do not use 1. 1 is not counted as prime because if you remember with our rule, a prime number is divisible by 1 and itself. So it's 1 and another number. 1 cannot take up both numbers. So 1 is not prime. Do not list it in your prime power factorization. Then we get to our gears for number 5. Gear A has 48 teeth. Gear B has 84 teeth. What we do on this is we take 48 and 84, and we're going to list its multiples. 48 times 1, 48 times 2, 48 times 3, 48 times 4. And that's what we have going. 48, 96, 144, 192, 240, 288, 336. I usually do 5 or 6 and then go to the second number and do 5 or 6. And if they still haven't met up, I go back to the smaller number and continue multiplying to get the bigger multiples until they match. On this one, we count. It took 1, 2, 3, 4, 5, 6, 7 revolutions to get to the same multiple as 84. So, well, the least common multiple. So the number they had in common was 336. It took 7 revolutions for A and 4 revolutions for B. So you're going to subtract the smaller number from the larger number, and that's equal to 3. It will take A 3 more revolutions than B to reach the same spot. Then we go to problem 6. And this is magic square, and it's really, really fun. So, magic square, you're going to have to notice that all numbers are consecutive. So, they're in consecutive order. Also notice that the numbers must have the same sum in all directions. So when we're working this, if at any time you get a sum that is different than the rest, it's wrong. That's just how it is. But it's fun. So we're given 0 and 1 on our table. So we can cross them out. I went ahead and rewrote a number list so that I can draw all over it. So I crossed 0 and 1 out. Step 2, to determine our magic number, we have to get the sum of all the integers and divide it by 3. And that's because this is a 3, it's an array of 3. So we divide it by 3. Our total number was negative 27. Do not forget the negative. Divided by 3 is negative 9. Negative 9 is our magic number. All sums will be negative 9. 3. The center number is our x. X is the magic number divided by 3 because 3, we have a 3 by 3. The center number is negative 9 divided by 3, which is equal to negative 3. So we have negative 3 in the middle. We can cross that one out. Then we are given 0, and 0 is x plus 3. So x is negative 3 plus 3 gives us 0. So since we know this one is x plus 3, we're going to work from there. 5. Step 5 is negative 4. Negative 4 is x minus 1. Then, oh goodness, I jumped ahead. So step 4, we're given 0 is x plus 3. Then that lets us know that this number right here, this, you're going to have an empty spot. The top right corner is x minus 1. X, which is negative 3, minus 1, which is negative 3, plus negative 1 is negative 4. So we can scratch that one out. Then we go to 5, step 5, which is green. So we have negative 4 here is x minus 1. Then this bottom right number is x minus 3. So negative 3 is x minus 3. So it's negative 3 plus negative 3 is equal to negative 6. So that's where we get that. Then we're looking at our top row. Well, this middle number is the only thing you should have empty. And you have a 0 that was given, and we figured out negative 4. Well, we know that this whole row is going to be equal to negative 9. So what is missing? Well, we know 0 plus negative 4 is negative 4. We need negative 5 to equal negative 9. So that's where we get that. Then we look at the bottom left. And that is x plus 1. So negative 3 plus 1 is equal to negative 2. There we go. And then step 8, and if you'll notice, all these colors match the step that it's in. The left middle is negative 2. Let's see, negative 2 is negative 7 from negative 9 because we have 0, which is given, negative 2 we figured out. Well, we were only negative 7 away. So that's where that comes from. Step 9, our bottom middle is negative 1. And if you want to check this left to right, you should get negative 9 on each row. Each diagonal is equal to negative 9. Each column is equal to negative 9. And that is the end of our written exam for Module 3. Thank you.